All right, so here's a help file for number 30. That is a problem in your chapter 3 homework. The problem is about a football player who claims that he kicked a ball at 30 degrees to the horizontal and the ball traveled 183 meters. And we're asked to estimate the alleged initial speed at which the ball was kicked, and just to make it easier for us to figure out whether it's a realistic number or not, they're telling us that 45 meters per second, that's a pretty mighty pitch for a baseball player. And here we have a football player claiming that the ball is traveling 183 meters. So basically, all we're given is initial speed is not given, but we're told that initial velocity makes a 30-degree angle, and we also know that the horizontal range is 183 meters. And so I'm just going to go ahead and write everything that I know down. Since it's a projectile motion problem, I'm preparing the table so I can separate horizontal and vertical motions so as to not to mix them up. And then that's basically all I have. And, time to start panicking as how am I going to solve this problem if I don't have enough information? Actually, you do. So all you need to do right now is to try to think and analyze what's going on and then play with the data. So I know that, so here's my ball, goes 183 meters. I know that the initial velocity is at 30 degrees. So even though I don't know what initial velocity is itself, I can at least take my first step and separate it into two components of Vx and Vy initial. Vx, as you remember, since we disregard any air resistance, is going to be consistent, and it's going to be V initial times cosine of 30. And then Vy is going to be changing because of gravity, and acceleration due to gravity is negative 9.8 or negative 9.81 meters per second squared. That is going to slow my ball down vertically to a complete zero, and then it's going to accelerate and hit the ground with the same initial speed. Anyway, so even though I don't know V initial, I will still go ahead and write these two into X and Y. And then I'm going to start thinking, okay, so what can I do to figure out the initial? So what do I know about the motion? So again, it traveled 183 meters. So hypothetically, I can figure out the time, right? If I know my initial velocity and initial velocity times cosine, and I know the displacement, horizontal, I can just take this delta x and divide it by time. I can also manipulate my initial velocity vertical and figure out how long it takes to, say, stop right in the middle, right there, when the initial velocity y turns into complete zero because of negative 9.8 meters per second squared. So what I'm going to do, I'm going to write this down. So from here, so these guys, I know for sure that is what is going on. It's traveling 183 meters because it has initial velocity on x and travels a certain amount of time. And I also know that g is going to slow it down to zero at some point. And so manipulating these two equations, I'm going to rewrite this for delta t. And then I'm going to think, how are these two delta t's connected? So this delta t right here is the total horizontal range over Vx. This is half time over, so I'm just ditching zero, and this is initial velocity y over g. And then how are these two connected? While it was slowing down to zero, that was exactly half time. And if I take 183 divided by my V initial times cosine of 30, I will get my total time. So the time to do this is only half of the whole time to travel 183 meters. So I'm going to go ahead and write this down. So this is my total time horizontally. This is half time. So I double it. And now, as you see before, I had these two equations separate. Now I realize that they are connected through doubling. And now I'm looking at Vx and Vy. This is a known, this is a known. These two are sort of unknown. However, I can connect them because initial velocity vertical is through sine and Vx is through cosine. So I'm going to rewrite these down. So what I do is I cross multiply and I end up with 2 V initial It's actually supposed to be negative, but I'm just gonna assume that G is negative as it is, so I'm gonna just drop minus. So I have G delta X, and then 2, and instead of V initial Y, I'm gonna say V initial sine of 30. Vx, which is initial final, whatever, it's constant. Vx is V initial times cosine of 30. So this is what we're looking for, right? So now, these guys are givens. I know this, I know this, I know this. So I have one variable. That is the variable that I'm looking for. So even though I didn't know a bunch of things here, I could still manipulate my formulas to give me something that I can work with. So from here, V initial squared is going to be gx over 2 sine of 30 cosine of 30. Again, I ditched this minus because I know that my G is negative 9.8. I just don't want to drag it. And also, if you remember this from trig, this right here is going to be sine of 60. If you don't, that's fine. I mean, seriously, you can just put sine of 30, cosine of 30 into your calculator. It's perfectly fine. I just remember it, so therefore, a shortcut. So from here, V initial squared is gx G delta x over sine of 60, and then I'm writing this down, so it's a square root 9.8183 over sine 60, which is 45.5 meters per second. It's even faster than the fastest, I don't know, forgive me for not knowing the stats. I assume it's the fastest if they gave it to us, or at least it's very fast, 45 meters per second. A pitch for a baseball compared to a kick of a football player, that is not realistic. So the claim that the guy kicked it at 30 degrees and it traveled 183 meters is not valid.